Hi, I'm Lou Brown with Spectrodyne, and today I'd like to show you some of the many ways that we can measure concentration in the NCS1 software. The measurement of highly accurate concentrations is one of the distinct advantages of the NCS1 over competing technologies. So let's take a look. During NCS1 acquisition, we can measure concentration in real time. This particular sample consists of 94, 150, and 208 nanometer beads, which you can see along the bottom here. The display shows that my overall concentration from 64 to 400 nanometers is 1.54 times 10 to the 10th particles per ml, and that we have a total of 6,750 particles. At any point in time, I can look at any part of this histogram and see, for instance, the exact concentration of the 94 nanometer beads merely by typing, say, 70 to 125, setting that. And now you can see that between 70 and 125 nanometers, we've got roughly 4 times 10 to the ninth particles per ml, and that there are 2,885 there. Let's look at the next peak. So we can simply go from 125 to 190, set that. And again, we see roughly 4 times 10 to the ninth particles per ml, which is exactly how I mix this. I mix this to be roughly 4 times 10 to the ninth particles per ml for each one of these. Okay, let's take a look at how you show concentration in the viewer. In this example, I've loaded up an extracellular vesicle sample result, as you can see over here. And if I want to find out the concentration overall, I merely can go in here and graphically select what I'm looking for. So I'll select from the noise floor up to the maximum and click on concentration. And you can see that it has reported the overall concentration of this sample to be 1.71 times 10 to the ninth particles per ml, and this n is the number of particles that were actually recorded during that time. There are two different ways of interrogating the graph for concentration. Down here you can see I've got a range selection which is graphical. So let's say I wanted to look at the concentration between 100 and 150 nanometers. So I would just outline that, hit concentration, and there's my result. Now you can see that it's not exact because I did this freehand. If I want the exact results, what I do is I just go in here and I'll type in 100 to 150 manually, hit select again, and again if I do the concentration, you're going to see it's going to be different because I've actually selected a slightly different area. Using the manual select is a way of getting the exact concentration in an exact range that you want versus graphical, which is a freehand, and therefore there will be some error based on just how you draw it. One of the more powerful features of the software is the ability to actually load more than one run and compare them quite quickly. So here I've loaded two different extracellular vesicle samples, and I simply switch to multi-mode and plot CSD. So now I can see the two samples overlaid. When comparing multiple runs when there's a broad dynamic range, it's much better to use a logarithmic Y scale. So I'm just going to go in and change that to log Y and replot. And now you can see that the green sample appears to have more particles in this lower range, and then the blue sample appears to have more particles in the upper range. So how would I actually determine to graphically show that? So let's go back in here to the measurement tab, and I'm going to look at from 65 to 75 nanometers. So I select that and click on concentration, and you can see that the green sample is more concentrated in that range. All right, but above 75 nanometers, it looks like the blue sample. So let's show that as well. So I'll go from 75 to 400, select that, and again click on concentration, and we can see that the blue sample in this case has higher concentration than does the green sample. So you can interactively select any range you want in order to determine the concentration. Remembering that the concentration is the integration under the curve for between any two values. Now, in these two particular samples, I happen to know that they were done at different dilution factors. So if I look at my metadata here, you can see that the first sample was done 1 to 1,000, and the second sample was done 1 to 10,000. So realistically, this is not a proper comparison. If I want to compare them properly, I need to scale the second sample by a factor of 10, since it was done at a 10x further dilution. So I just put 10 selected, and now if I replot, you're going to see the actual differences here. So these are now at the same relative concentration. So now if I go and I select the entire range here on both of these samples, you're going to see that obviously the green sample is much more concentrated, and in fact it's more concentrated by a factor of about 10. In the same way as I did before, I've gone back and I've corrected both of these samples back to stock. So you can see that 10 to the 13th, I'm at a much higher concentration here. And again, I just did that by correcting each individual run for its correction factor. So now, what happens if I want to output this data in some form that I can look at in, say, Excel? I simply go to the Data Output tab, and in this case, I'm going to do a size distribution data, and the software gives me the ability to bin it however I want to and to use number or volume weighting. So for this demonstration, I'm just going to do equal bins of 10 nanometer. I'm going to do number. So I just say export, and I'm going to put this on the desktop, and I will save this as test 1. And now it's exporting the report. It's complete. And if I go to my desktop, I can open that file. And you can see that there are two tabs here. The first is the metadata for each individual run, and the second is the actual distribution data. And again, I've binned it in 10 nanometer bins here. Okay, so now that's in Excel, and I can do whatever I want with it. If I'm interested in looking at particular ranges, I can do what's called a range report. And to do that, I simply go into this form, and I'm going to do ranges of about 50. So I'm going to say from 50 to 100, and I'm going to add another range of 100 to 150. I'll add another range of 150 to 200. And if I want to save any kind of thing like this, I can save these so that I can reuse these. I don't have to input these every time. But let's just go ahead and export this report. And again, I'll put it on the desktop, and we'll call it test 2. Export's complete, and let's bring it up. So here is test 2, and you can see basically for each run that I've got the range, that I've got the concentration from 50 to 100, 100 to 150, 150 to 200. So I can make any sort of report on concentration ranges like this of interest, and I can save it and reuse it later. So I've shown you a few of the ways that we can measure concentration inside the NCS1 software. I hope this was informative. And please stay tuned to our website for more videos as we publish them. Thanks very much.